Good day everyone, good day. Here with me I've got this question, which is 2024 question 10, okay, of the ECZ. So the information reads, the values of x and y are connected by the equation y is equal to negative x cubed plus x squared plus 6x. Some corresponding values of x and y are given in the table below. So these are values of x and y. Then what we have not been given is this part here. This one here is 8. Okay, calculate the value of q. So now to calculate the value of q, I will use this space here. We have y is equal to we are using this one here, which is negative x to the power 3 plus x squared plus 6x. So here we are saying that where there is y will be replaced by q is equal to negative open bracket, we'll get this 4 and replace where there is x, okay, the power 3 plus 4 here squared plus 6 the power 6 by 4. Okay, so once we replace this, you find that once you compute this on your calculator, this is paper 2, your answer is going to be negative 24. So here at q here, we are saying that it's what? Negative q is equal to negative 24. Okay, so here q is equal to negative 24. So this is what we are going to use here. So we can write this on the graph paper. Okay, so we can write this on a graph paper. Now before we take a look on a graph paper, I want us to read this the second question. Okay, this you answer negative 24, you get the 1 mark. Using a scale of 2 centimeters to represent 1 unit on the x-axis. Okay, so the x-axis we are going to use 2 centimeters to represent 1 unit. Now the range is from negative 3 to 4, and 2 centimeters to represent 10 units on the y-axis. For negative 30 is less or equal to y is less or equal to 20. Then draw the graph of y is equal to this here, cubic function. So now here we will use this one. We are going to use the graph. So using this graph, we are saying that the first equation, the first question there, which is 1, we said our y is equal to negative 24. Okay, this is the value of p, sorry, the value of q, Then having this, we are told that in this y-axis, the range here from this side, it's from the positive one there is what? A 20. This side here it's 20 in the value of y. Then this side we have so let's say we are going to divide this side, this graph. We have, let's say, 10 20 10 0. Okay, 0 here. So now 0 this side, 1 2 3 4. Okay, so here we can have 1 this side. Hope you are seeing. 1 2 3, okay, 4. We have this side here. This side again negative 1. Okay, then 2 here, negative 2, negative 3. So this is what we have. So having this here, it's a 0. Okay, so I'll draw this I'll draw I'll draw the y-axis. Okay, the y-axis. Okay, so this is my y-axis, and then I'll say, okay, it's not visible that much. Let me use a pen. I'm using a pen. I want you to see how or where this y-axis lies. So here, this is my y-axis, okay, and this is x-axis. So even this side, I'll also use a pen. Okay, use a pen even this side so that it's visible. Okay, so here we have something like this. So here it's 1, we have a 2 here, okay, 3, 4 this side. Then having this side, we only have a 10, and here 20. Okay, 20. This side we have negative 10, negative 20, negative 20, and also negative 30. Okay, this is what we have in y-axis. So having something like this, well, we are going to plot the points. Okay, we are going to plot the points. Okay, so here these are the points that we are going to plot. We have negative 3, 18. So negative 3 is this side, and 18 here, this is 10. This is 10 here, and then 18 is this side. So now we have these 2 units. 2 centimeters is representing 10 units. So here we've got 10, 11, 12, 13, 14, 15, 16, 17, 18. So my 18 is this point here. This is 18. Okay, this is 18. Then negative 2, 0. Negative 2, 0 is at this point here. This is negative 2, 0. Again, we have negative 1, negative 4. Negative 1 is this part here. Negative 4. Now we count from here: 1, 2, 3, 4. So this is my 4 here. Okay, this is my 4. Then again we have 0, 0 is this point here. 0, 0 at this point. Then again we have 1, 6, which is positive. 1 is here, so this is 5. 6 is this point here. Okay, this is 1, 6. Then 2, 8. This here is 8, so it's 2, 8, 6 there. Then our 8 is this side here. Okay, here this is 8. 8 is at this point. Okay, then we have 3, 0. 3, y is 0, 0 at this point. Then we have 4, negative 24. 4 is here, negative 24. So here we have 20. Okay, 20, 24 is here before the blue one, this line, which is 5. This is 25, so 4 is there. Then having this, we can draw the curve. Okay, so we're going to draw the curve. Remember, when drawing the curve, okay, we're going to draw the curve. So here now your curve, it will look like this. So I've used a pen so that it is more visible. Okay, so now your function, your cubic function, it will look like this. So here you even name this to be, and so naming this, it's going to be y. Okay, right here, which is y is equal to negative x cubed plus x squared plus 6x. So this is the curve. Okay, so having this, you get a 3 mark, plus that one you get a 4 mark. Okay, so we move on. We have this equation again. Solve the equation, this one, negative x cube, okay, negative x cube plus x squared plus 6x is equal to 4 minus x. Okay, so having this one, we know that this equation, the one that we have been given here, which is negative x cube plus x squared plus 6x, okay, is equal to 4 minus x. Then we know that this equation here, okay, this equation here is equal to this one. Now this one, since there's an equal sign, so we are saying that this equation is equal to y. So where there is this equation replaced by y, it will be y is equal to 4 minus x. Okay, so this is the linear equation that you have. So having this, you can draw a table of value. Okay, so let's draw a table of value. Okay, we'll draw a table of value here, and this table value is also part of your solution. Okay, so you can put it on your graph paper so that even those who are marking are able to see that these are the values that you've used. Okay. Okay, so I'll put here it's x, there y, and for this you can just use any values for x, as long as they are in this range. They are in this range, within the given range. So here, let me say I will use a 0 this side and also a 0 this side. So now once I put a 0 here, for when x is equal to 0, the value of y will be what? 4. Okay, the value of y will be positive 4. Now when the value of y is 0, what will be the value of x there? So we are saying that where there is y, you replace by 0 is equal to 4 minus x. Now we transpose this to the other side, or this one here to the other side, it will become positive. So it will be x is equal to 4. So here where there is here you put what? 4. Okay, so when the value of y is 0, the value of x is equal to 4. When the value of x is 0, the value of y again is going to be what? It's going to be 4. Okay, so here we can plot this point. So we are saying 0, 4. 0 it's here, 4 is somewhere there. Okay, so it's here, this is 0, 4. And then again we have 4, 0. 4, 0, it's right here. Okay, at this point, this is where there is 0, 4. Then you draw a line joining these 2 points. Okay, So we draw a line. Okay, so drawing this, so our target is to join the points. Okay, so I've drawn the line. This is my line from here up to this side. So here I'll name this line as EHC y is equal to 4 minus x. Okay, so this is the name of what this linear line or straight line. It's y is equal to 4 minus x. Now you remember the question is solve. Okay, we are solving. So this is 3 1. Yes, it's 3 1. So 3 1 solving. I'll put here the answers. Okay, answers is 3 1, 3 there, 1, 3a. Okay, the first question is 3a. So now to solve for x, to solve this equation, you get your values where this line is cutting the curve. Okay, so as you can see here, this line is cutting the curve at this point where there is okay, I will use the pencil here so that you are able to see. Let me use a pencil here. So here there is at this point, this is where the value of x, where I'm going to get it is at this point. So here I'll say it's 2.9. that is the value of x. So here the value of x, I'm saying that it's x is equal to 2.9. okay, 2.9. then again x is equal to at this point here, at this point is 0, 0, so here I'll say 0, 5. okay, 0, 5, 0.5. okay, the value here is 0 here, 0.5 here. okay, that is, I can't say 5 point something, so I'll just say 0.5. okay, then at this point again it's a negative 2, negative 2.5. yes, negative 2.5. then x is equal to negative 2.5. so this negative 2.5 it lies here. This is where we can find that answer, negative 2.5. it's at this point. okay, so having this, which means we've answered this equation here, the one that they've said solve the graph, the equation, this one. Then we move to B. 3b says estimate. okay, let's estimate the gradient of the curve at the point where x is equal to negative 1. So here they want us to estimate the gradient at the point when x is equal to negative 1. So x is equal to negative 1 at this point. So at this point we are going to draw a tangent line. okay, so a tangent line is a line that touches the curve at just one point. okay, so it will be like this, and then we draw like this. This is my tangent line, which is touching this curve at this point. okay, so this is my tangent line. So having this tangent line, we can get here, we know the coordinates at this point. It's 1,6. You can ask, where have where did I get this 1,6? 1,6 it's here, 1,6, because we are told that when x is equal to 1, so and the 1,6 is at this point here. This is 1,6, so this will be my first point. The other point you can pick anywhere, okay, where anywhere along this the tangent line. So I've picked 1,6, and then the other one I'll pick it from this side, where I'll say here, I'll say it's 0,2, okay, 0,2, okay, so here it's 0,2. Then we'll say it's B. So now the points that I'm using is 0,2, each 0, then 2 there. I'm picking it from this side, 0,2, okay, close. Then again here I have 1,6, the one that I was given. Remember the question says estimate, so it means that the answer will vary according to the points that you've selected. Okay, so here we'll use this gradient. M is equal to y2 minus y1 over x2 minus x1. So these are 2, these are 1. Okay, then this, we know this is x, this is y, x, y. Okay, so y2 I'll take 6, so here I'll say 6, which is y2, minus y1, which is 2 this side, over x2, it's 1, minus here it's 0. Okay, this is what I have. So this one and this one, then having this and this will get a 4, then over 1, then this into that is going to be what? A 4. So here my gradient is equal to what? M is equal to 4. Or if you want, you can simply say the gradient is 4. Okay, so this is my gradient. Okay, so this is how you can answer this question on a graph paper. Okay, so please don't forget to subscribe and share the video, and also liking it. Okay, we move to question B. Okay, so now to this question B, the question reads, find the equation of the normal to the curve. Okay, find the equation of the normal to the curve. So here we have been given this is y is equal to x squared plus x plus 2 at the point, at this point. So now for us to find the gradient here, we are going to differentiate this. So differentiating this one, will say it's dy. Okay, we have dy here, dx. dy dx is equal to this one. We drop this one and multiply with the coefficient of what? X. So this one, it will be 2x plus here it's 1. Only differentiate with respect to x. Okay, so now, and this one is passing at this point 1,4. Okay, 1,4. Here what you want is the gradient. So now this is the way of calculating what? The gradient. So having this as the way of calculating gradient, we are saying that where there is x will replace by 1. So say 2 open bracket, where there is x you put 1, we close, plus 1. Then what do we get? 2 times this, you get a 2, plus 1, you get a 3. So here you are going to have a 3. So your gradient here, m is equal to 3. So now the question is find the equation of the normal to the curve. So this is the curve. What they want is the equation of the normal. So the equation of the normal, we say m1 times m2 should give us -1. Okay, which means it is making an angle of 90 degrees. Okay, if I told you I've got this is the equation of the curve, then you also have the tangent this point. Okay, the tangent this point, then the normal, it will come like this. Okay, making this point at 90 degrees. This is what why we say m1 times m2 is equal to -1. Okay, so now if your m1 is 3, 3m is equal to -1. So now for us to find the gradient which is perpendicular to this one, it will be over 3 over 3. There goes. So our m is equal to -1 over 3. This is the gradient. Okay, adding this gradient, we are going to use the equation of a straight line to find the equation of the normal. Okay, with this gradient, not this one, but this one, the perpendicular one. So say y minus y1 is equal to m open bracket x minus x1, we close. Okay, so we have these two coordinates here. So y1 is 4, okay, which is this one, then is equal to here. Now where there is m, we'll replace by this gradient, which is -1 over 3. We close. X, it's x there, minus x1, it's 1, then we close. So adding something like this here, you can say over 1. We can multiply this times this, this times this. So 3 times this here, you are going to have something like this, 3 open bracket y minus 4, we close. Then this times this, here again you have -1, which is this one here, you multiply by x minus 1, we close. Okay, and then here you say this and this, you get a 3y minus this and this, you get a 12 is equal to this and this, you get a -x. Then this negative and negative, you get a +1. Okay, so here we don't say a -1x, no, it's just a -x. Here we find the additive inverse of -12, which is +12. So here we'll say 3y is equal to -x plus 1 plus 12. Okay, this 12 here, which is once it's closer, the equal sign to be +12. Okay, so having this, we can work out this and this, which will give us 3y is equal to -x plus 13. Okay, so this is the equation of the normal to this curve. This is the equation of the normal. Thank you very much.